This is our first unit of Algebra 1B, Systems of Equations, and our first lesson is graphing inequalities on a coordinate plane. Before I begin showing you how you graph inequalities on a coordinate plane, let's review how we graph equations on a coordinate plane. When you have a formula or an equation in the slope-intercept form, or where y is equal to mx plus b, that b value represents the y-intercept. If we have our axis here, this is our x-axis and this is our y-axis. So this equation here crosses our y-axis at -1. So here I'm going to plot -1 for you. The m value stands for our slope. Remember, your slope is the rise over the run. And that's rise or fall. Fall if the number happens to be negative. And we always run to the right. Run right. So if I were to, from my y-intercept, I can find the next point on my line using that slope. I have to rise 2, go up 2, that takes me at +1, and run right 3. So that leaves me with a point right here. After I plot my 2 points, then I can connect them with a line that passes through them, going in both directions here. And there I've graphed the line. Now let's also review some concepts with inequalities. So far in Algebra 1A, the only graphing of inequalities you've done is just on a number line. Basically, just like if we only had the x-axis. Remember if we had, for example, if we had x is greater than 2, what did we have to do? We had to plot the 2 and make it an open circle. We kept it open because there was no equal sign underneath our greater than sign. If it were closed, it would be we would use x is greater than or equal to 2. If that was the case, if it has that equal sign underneath our greater than, then we'd have to color it in, or it would say to be closed. So this was open, and this is closed. And if it was greater than, then our arrow then would point to the right. If it was less than, then our arrow would be pointing to the left. Or as we're getting bigger along our x-axis versus less than on our x-axis. So I'm going to demonstrate how you can apply both of these concepts to graphing inequalities on a coordinate plane. When you have more than one variable in an inequality, like what we do here, our x and our y values that you see here, then we cannot just graph this on a number line. We have to use a coordinate plane. Now to begin graphing this, we would graph it just as if it were an equation. We start with our y-intercept and plot that point. So our y-intercept then would be the constant that's being added or subtracted to x, or a +3. Plot that point. And then you'll find your slope use your slope to find the next point on the graph. Well, our slope is 2, or the same thing as 2 over 1. So we go up 2 and over 1 to plot our second point. Once you plot both your points, just like if it was an equation, then we would draw a line, a straight line as possible, to represent that equation. Now what's different between an equation and an inequality is if this line is going to stay solid or dashed. So just like, remember when we had the greater than sign but without any equal sign here, how we said that that was open? Or if there was the greater than and equal to sign, where we had that equal to sign underneath it, how this was closed? In a way, we have an open and closed line, but instead of saying open and closed, we're going to call it dashed, dashed, or solid. So whether or not there's an equal sign underneath our inequality, like in problem example 1, or if there's none, like in problem number 2, tells us if our line stays a solid line. For example, in example 1, we do have a solid line here, so I'm not going to do anything differently to this one. Let me go ahead and begin doing our graph for problem number 2 so that you can see the difference. So in problem number 2, I'm going to go ahead and graph it just like as if it was an equation. I find my y-intercept of positive 4, and I use my slope of negative 3 over 2. So that means I have to go down 3, 1, 2, 3, that puts me on positive 1, and run right 2. There's my other point. And I'm going to connect the dots with a straight line. Now what makes this one different from example 1 is that I do not have the equal to sign underneath my less than sign. So what I will need to do is turn this into a dashed line. You can do this one of two ways. When you have your ruler, you can either make it dash as you're drawing your line, if you notice it ahead of time, or what I like to do is after I draw my solid line, I go back with my eraser and just kind of make little eraser marks to turn it into a dashed line. So that's the difference between the equal to or the not equal to. Now we're not done with either one of these problems. We still have to represent that one is greater than and one is less than. So if you see the greater than sign, then you're going to have to do, or your less than sign, then we have to do some shading. And if it's greater than, then you're going to be shading above the line. If it's less than, then you're going to shade below the line. So in example 1, we have the greater than or equal to sign. That means that we need to shade above our line, or as we're going up on our y-axis. Now I'm going to put two little arrows to point in the direction that I'm going to shade on each one of these. And I know at first you're like, I can do this without doing that. But this will really be a very helpful tool for you later on when we're solving systems of inequalities. So in example 2, you see the less than sign, so we need to shade below our line, or as we go down our y-axis. So I'm going to put two little blue arrows to let you know which direction we're shading, and then I'm going to shade in that area that it's pointing down. You don't have to color it in solid, just kind of scribble, and that's fine. Everybody knows that that's all that is just you shaded it. Okay. If you haven't done so already, go ahead and copy these two problems down on your paper and write down the notes that I wrote in the center for you before I go on and show you example 3. Okay, if you're ready for example 3, now we need to graph the line just as if it was an equation instead of an inequality. And if you're looking here, well, where's your y-intercept? Well, where do you expect to see it? Right here after that x? If you don't see it, then what should it be? It's just like saying it's a plus 0 or at 0. Well, where's 0 on your y-axis? Right there at the origin. So if you don't see a number being added or subtracted to x, then you know that it starts at your origin. Then what's your slope? The slope is the number that's always in front of your x term. So in this case, our slope is equal to, well, if you don't see it, that's that invisible 1 there, but don't forget the sign that you see there. So it's a negative 1 over 1. So we go down, or we fall 1, and we run right 1. So down 1, right 1, takes you right there. Connect the dots. Alright, now look at your inequality. First we need to ask ourselves, should it be dashed or solid? What did you say? Hopefully you said dashed, because there's no equal to sign underneath the greater than sign. So you need to go back and erase or make it dashed. The next step is you need to shade. Well, do we need to shade above the line or below the line? It's greater than, so you need to shade above. And that's it. What that shading and those lines represent is all the possible solutions to the inequality. As long as it falls anywhere on a shaded or solid line, it's a solution. When you have a dashed line, it means that it can go all the way up to that dashed line, but not directly on it or any point that falls on that dashed line. Let's do example 4 together. Okay, you need to draw the line as if it was an equation. So where would you start? Did you plot a point right there at -3? Then you need to use your slope. If I count down 3 because it's negative, by the way, if you ever see a negative off to the side of your slope, remember that negative always is associated to your numerator, never to your denominator. So we'd have to go down 3 and run right 4. It's right there. Connect the dots. Oops. Do need arrowheads on both ends. When you're taking the ACA, if you do not choose the line tool that draws the arrowheads on the ends, you will get the problem wrong. It needs to be arrows, not aligned segments. Alright, so you've drawn your line. Does it stay solid or do you need to dash it? Writing's there. Because it has the equal to sign, it stays solid. Now you're ready to shade. Do we shade above or below the line that you've drawn? Because it's less than, you shade below. Alright, attempt the next 6 problems on your own, only stopping and starting this video when you're ready to check each problem. And if you notice that you've made a mistake as I go over the explanations, then push pause, try to fix it from the mistake that you made, and see if you can get it right from the rest of the problem. Alright, push pause and do problem number 5 and push play when you're ready to check. Alright, problem number 5. If we were to graph 5, you would start at the -5, plot that point, and then we have a slope of equal to -3/1. Well, if we try to go down 3 because it's negative, we fall off the graph. So what do we have to do? You have to reverse it. Reverse everything. Change the 3 to a +3 and the 1 to a -1. That means you'd have to go up 3, 1, 2, 3, and back 1. That's how you would reverse it. Now connect your dots, your points, to draw a line. Ask yourself, do I keep it solid or do I need to dash it? Because there's no equal to sign, I have to dash. Ready to shade? Because it's greater than, I need to shade above the line. Above or as you go up on your y-axis. So here's my y-axis. That direction is going up or is above, so this is the side that you would shade. A little helpful tool for you if you're getting confused about what's above and what's below is imagine a little person walking on the line. Above would be in the sky, below would be on the ground. Alright, try number 6. Push pause and push play when you're ready to check. Problem 6. We'd find the y-intercept of +2. Using our slope, we'd have to go down 1 and over to the right 5. Connect our points with a straight line. And because it's less than but not less than or equal to, this is a dashed line. Finally, we need a shade. It's less than, so that means it's below the line. So you shade below. If you're ready for number 7, go ahead and push pause, do number 7, and push play when you're ready to check. Number 7, you plot the y-intercept of +4. Our slope is, you see next to x, you see just a negative sign there. That means -1/1. So you go down 1 and to the right 1. Connect your points with a straight line. Because it has the or equal to sign underneath the inequality, you keep that line solid. And because it's greater than, that means as we go up on our y-axis, this is the area that needs to be shaded. Problem number 8. Graph the y-intercept of -4. The slope is, well, our x has a 1 in front of it, or same thing as 1/1. So we go up 1/1 to find the next point on the graph. Connect your points with a straight line. Because it does not have the or equal to sign, we have to dash our line. And because the inequality says greater than, that means as we go up on our y-axis, so this is the area that you would shade, everything that's above our line. Alright. Push pause and do the next 2 problems, and push play when you're ready to check. Problem number 9, you would have to find the y-intercept of -1. The slope is 1/3, so you go up 1/3. Connect your points with a straight line. It has the equal to sign, so we keep it solid. And because the inequality says less than, that means as we go down on our y-axis, that's the area that you shade. Last problem, number 10. Find our y-intercept of +5. The slope is 1/1, so up 1/1. Connect the points with a straight line. Because there's no equal to sign, we need to dash it. And the inequality is less than, which means as you go down on your y-axis or below the line.